Compare and contrast classification algorithms with regression algorithms. Classification algorithms. Classification algorithms are used to predict discrete outcomes or categories. They assign input data into predefined classes or labels based on the features of the data. Types of algorithms. Some common classification algorithms include logistic regression, decision trees, random forest, support vector machines, naive Bayes, K nearest neighbors. Evaluation matrix. Common metrics for evaluating classification algorithms include accuracy, precision and recall, F1 score, ROC, AUC. Use cases. Examples of classification tasks include email spam detection, disease diagnosis, image recognition, sentiment analysis. Regression algorithms. Regression algorithms are used to predict continuous outcomes. They model the relationship between a dependent variable and one or more independent variables. Types of algorithms. Some common regression algorithms include linear regression, polynomial regression, ridge and lasso regression, decision trees and random forests, support vector regression. Evaluation matrix. Common metrics for evaluating regression algorithms include mean absolute error, mean squared error, root mean squared error, R squared. Use cases. Examples of regression tasks include predicting housing prices, forecasting sales and revenue, estimating demand for products, predicting temperatures or weather patterns. Key differences. Nature of the output, classification, regression, evaluation matrix, classification, regression. Use cases, classification, regression, algorithm types. Conclusion. Both classification and regression algorithms are fundamental to supervised learning and have distinct roles in predicting modeling. Classification is used for categorical predictions, while regression is used for numerical predictions. Understanding the differences between these two types of algorithms helps in selecting the right approach for a given problem and effectively evaluating model performance. Describe the various splitting criteria used in decision trees, such as Gini index and information gain. The Gini index is a measure of impurity or purity used to evaluate the splits in data sets. It quantifies the likelihood of incorrect classification of a randomly chosen element if it was labeled according to the distribution of labels in the subset. A Gini index of 0 indicates perfect purity, where all elements belong to a single class, while a higher Gini index signifies greater impurity. Calculation. For a binary classification problem, if the proportions of the two classes are P and Q, the Gini index is calculated as. Decision trees aim to minimize the Gini index at each split, choosing the split that results in the lowest Gini index. Information gain. Information gain is based on the concept of entropy from information theory. Entropy measures the level of disorder or uncertainty. Information gain calculates the reduction in entropy after a data set is split on an attribute. A higher information gain indicates a more informative split. Calculation. Entropy E for a binary classification problem with probabilities P and Q is. Information gain is the difference between the entropy before and after the split. Decision trees use information gain to select the attribute that maximally reduces entropy, thus providing the most significant information about the classification. Summary. Both the Gini index and information gain are crucial for evaluating potential splits in decision trees, ensuring the chosen splits maximize purity and informativeness, leading to effective and accurate tree models. Discuss the different types of classification algorithms and their typical use cases. Types of classification algorithms and their typical use cases. Logistic regression. Type. Use cases. Description. Decision trees. Type. Use cases. Description. Random forest. Type. Use cases. Description. Support vector machines. Type. Use cases. Description. K nearest neighbors. Type. Use cases. Description. Navy base. Type. Use cases. Description. Neural networks. Type. Use cases. Description. Summary. Each classification algorithm has unique strength and is suited for specific use cases, from simple binary classifications to complex tasks like image recognition, enabling tailored solution for diverse applications in various fields. Explain how decision trees perform feature selection automatically and the benefits of this capability. Automatic feature selection. Splitting criteria. Decision trees perform feature selection automatically during the tree building process by evaluating all available features and selecting the one that best splits the data at each node. The criteria used for this selection include measures like Gini index, information gain, or chi-square. Iterative process. At each node, the algorithm iterates over all possible features and their potential split points to find the optimal split that maximizes purity or minimizes entropy. Hierarchy of features. As the tree grows, features that contribute more to the reduction of impurity or increase in information gain are used higher up in the tree, effectively ranking the features by their importance. Benefits of automatic feature selection. Simplicity and efficiency. Reduced complexity. Efficient computation. Improved model performance. Avoiding overfitting. Enhanced interpretability. Adaptability. Handling irrelevant features. Flexibility with feature interactions. Summary. The ability of decision trees to perform